In this video, we're going to give you an overview and explain the options within Aspire's Create Shape modelling tool. This function lets you choose a round, triangular or flat shape and apply that across the area of a selected vector. You can see some examples of this on the screen. So let's begin now by starting a new copy of the software and opening a file that we can use in order to show you different examples. So let's choose the option here to open an existing file, and from the project folder we're going to select Create Shape Example.crv3d and hit open. And here you can see we have an Aspire file that just has a simple set of vectors that have been created in it that'll help us to demonstrate the Create Shape function. In order to see what's going on and to make it easier to select different vectors, I'm going to come up and click on the icon here under 2D View Control to tile the windows horizontally. So that's the second of the two tile icons. And then we're going to come down and click on the Modelling tab, because the Create Shape function is the first icon located under the modelling tools. As it says here, Create Shape from Vectors. We can click on that and go into the function itself. Now to start with, let's give you a quick demonstration of just how the process for making something with this feature works. First, you need to pick a vector or multiple vectors that will represent the boundaries that you're going to apply the shape to. Then you're going to pick your shape profile, either the round, angular or planar here, so basically a flat profile, and then we'll choose various options within the form to control that shape in a little more detail, maybe by indicating the angle, some vertical height on it, or how we might want to limit the height of it. And we'll run through all these different options as we progress through this demonstration. Once we've set the options for the shape, we come down to the bottom area of the form, and as with any components that we create in the software, we're going to choose the combine mode of how this is going to interact with other components we might have in the part. So here these four choices we have are to add, subtract, merge high, merge low, and these are explained throughout the tutorials and more specifically in the component tree tutorial. Then we have the choice of giving our component a name which will help us to understand what that component is doing. That may be a name that's descriptive of the shape, or it may be a name that's descriptive of what it represents in our design, such as leg, wing, eye, something like that, depending on what you're making. Here I'm just going to call the component we're about to create dome. I'm going to hit apply, and you can see what the software has done. It's taken this round 45 degrees and it's created a shape based on the vector we've currently got selected. In the 2D view we can see a yellow preview of that shape, and in the 3D view we can see the actual result of it displayed as a 3D object. If we were happy with that, then we just have to hit the close button, and there we can see now in the component tree we've got a new component called dome, which is the name we just gave it. If we were to click on that component, we'll see it highlighted in the 2D and the 3D view, and we could work with that as we could with any component in the software. If we just click it again, drag it around, change its size and manipulate it in the same way we could with any other 3D shape we've created. Here what I'm going to do though is delete this so we can go ahead and show you some of the other options within the Create Shape function. Let's just right mouse click there, choose the delete option. So we've removed that from the component tree, and now we're back to having no components. I'm going to go back into Create Shape from Vectors. Now a typical process within the software is going to be to select one vector, create the shape on it. So here we'll just hit apply on the circle there, and then to come down and click on the button here to start a new component. So if we click that, you can see that that one becomes deselected, and now the software will let me choose a vector outline. I can specify a different shape, hit apply, and then click again on start new component, click on the next shape, choose an appropriate shape for that, hit apply, and work our way through creating a set of different shapes that we can individually edit after we've used the Create Shape function. For the purposes of this demonstration though, I'd like to show you how different choices we make within the form will react with different types of vector outline. So what I'm going to do here is just close this. We'll go ahead and select all these components, right mouse click and delete them, and we'll come back into the create shape form, and I'm going to select all these vectors. So in effect, what we'll be doing as we work through the form is creating a single component each time that just happens to be within 5 different outlines. As I say, this would be untypical of the way we'd work, but it will help to demonstrate the different shapes and the different choices we can make in the form on different types of vector. Let's start here with the round profile and look at the effects of adjusting the angle. Let's click apply for the 45 degrees and we can see what that looks like across our 5 different shapes there. To change the angle, we can type in a value in here. So if I enter 60, hit apply, we can see how that looks. And as well as entering specific values, if we're not sure, we can just come in and use the slider and keep tweaking that and get it to dynamically update until we can see the type of shape we're looking for. It's also possible to go to negative values here in order to create a shape which goes down from the modelling plane. You can see just by sliding that and letting go that it's updating in the 3D view and showing us immediately what we're going to get from that particular combination. Let's change now to the angular shape and have a look at that as well. Here we can see we can enter a value, hit apply down the bottom here, or once more we can use the slider in order to see different effects. One thing it's worth noting is that if you get to 90 degrees, then the software is just going to default to the middle setting because it's not possible to have an angle at 90 degrees. That would be a vertical edge. So you can see as we move this down, we get very, very high angle all the way down to low angles here, and again into negative shapes if we want, going down from the modelling plane. Now if we come down and choose the flat profile, you can see that the angle has been greyed out, and that's because it has no effect on the flat profile. All that you do with this particular shape is to give it a vertical height, and that's done by entering a base height or by using the slider here. So let's say we wanted all these shapes to just be a flat plane which is at 1/8 of an inch. We can enter 0.125, hit apply, and there we can see we've just got that vertical edge coming up from each of those vectors up to a height of 0.125 of an inch. Something worth noting there is if you look at the very bottom on the right hand side of the interface, you can see an X, Y and Z value being displayed. That's showing me where the cursor is in the 3D view. So it's showing me its XY position as I move it, and also as we go over a shape it shows me the Z value for that shape, and we can see it's 0.125 as we just specified. As I mentioned, as well as entering the base height, we can also come in and use the slider again in order to dynamically adjust these different positions. The base height doesn't just control the flat profile though. We can also use that in combination with the other shape profiles here. If we come back to an angular shape, maybe we'll type in a value of 30 degrees, set the base height to 0 and hit apply. So now you can see we've got a 30-degree domed shape on each of our vectors, but we could say to the software that we'd also like underneath that to have a vertical height raising it up. So perhaps let's enter a value of 0.25 of an inch, come down and hit apply, and now we can see if we roll that around we've got our 30-degree dome, but it's sitting on top of a vertical edge which is coming up 0.25 or a quarter of an inch. So we're actually getting a combination of the two things that we've set there over all our different vector outlines. So let's reset the base height back to 0 again here, and I'm just going to push the angle up somewhere close to around 60 degrees. Now you can see if we look at each of our shapes, then the height that it reaches is essentially based on the width of the shape, because the software is taking this cross section and applying it across the area of the vector we've got selected. How high it gets is dependent upon the width of the different areas in the vector. The wider something is, like the dome here, then the cross section can be stretched all the way across it. And then as we come to other shapes, perhaps where we can see the width vary, here you can see how this blob shape gets thinner in the middle there. So the higher parts at the top and bottom where it's wider, and also on the sort of teardrop shape here we can see how at the thinner area the cross section is not going to be as high because it's not being stretched as far across. Over on the letter T there you can see that is even more defined because we've got areas that go from being very thin to very wide in a short area across the angles. So this is a very important concept when using the create shape function, to understand that if we don't limit the height, the software is just going to use the width and find the highest point it can to stretch whatever profile and angle across in order to define the shape. Now, as well as the software just finding its own height because we don't set a limit, you can see that in this final height area of the form we also have choices to limit the height and scale the height of the component we're creating. If we choose the option to limit to height, what we can do is either use the slider or type in a value and tell the software to actually flatten the object off at that particular height. So here maybe we'll enter something quite low to start with, 0.05, hit apply, and we can see the effect that's going to have on our shapes. If we look closely we can see we're still using a rounded profile which we're specifying at the top here, and we will be using this angle, but now we've told the software as soon as we get to this height of 0.05 to limit it and to flatten that off. If we want we can increase that slowly so we can see the effect of how that's going to progress further and further up the shape we're creating before it gets flattened off, and as I say that could also be indicated with the slider here as well. Now if you get to a point where the height you've specified is high enough that some shapes are not affected, like the T here, no part of that gets up to this height, so that is now gone back to its standard round shape as defined at the top, whereas some of these other shapes are getting to heights which have got more value than 0.255, and so they're still being flattened off in some areas. So if we just keep going until we get a height that is actually larger than any of the shapes that we've defined, then we'll see that none of them will be affected by that because it's not actually reaching that height in order to limit it. So that's quite a nice way to control the height of the shape, but it does affect our profile by actually adding this flat area on the top of each of our objects. The other choice is to use the scale to exact height, and this, rather than flattening it off, will just scale the Z height of the component we're creating to the value that we specify here. And what it will use to do that is the highest point of our component. So in this case that's actually going to be the peak of the dome that we're creating. So if we set our value to scale to height of 0.5 and hit apply, what that's going to do is scale the dome, which is the widest thing we've got, to be 0.5 of an inch high, and everything else will be scaled proportionately. Now, as I mentioned at the beginning of our demonstration, more typically we'd work on a single vector at a time. If I'm to come down and click on the reset button, we can see that'll leave my vector selected, but it'll reset any shape that I was currently working on. And now what I could do is just click to deselect the vectors. Now I could select just the dome, and we could come in here, hit apply to give it that angle and that height. Then we would say start new component, click on the rectangle here, and now within here we might specify that to be, say, 45 degrees and scale to a height of 0.25 and hit apply, and now I know that the height of that object will be 0.25 of an inch because it's the only one I have selected. Click start new component, click on this shape. Again, we could change the angle if we wanted for that shape. We could change the height of that, so maybe say we want to scale that all the way up to 3/4 of an inch. So each individual shape I can specify the values precisely in order to define it to look exactly as I want it to. Let's just finish off here. We'll click on the teardrop. Now you can see there, because I didn't click start new component, we've lost the information that we had for this previous shape. So if I wanted to keep that shape, I'd come back, click on it, hit apply, and then make sure I hit start new component, so we actually in effect save that shape as a component on the component tree, and now we can select the next vector and that'll retain the shape there. Here with the next vector, maybe we'd say we want to do this an angular shape, 30 degrees, put on a base height of 0.25, but then put on a scale to height of 0.25 and hit apply. Now what we're going to get is a combination of these two heights that we've specified. So the total height of this shape, if we look at the cursor there, is right around 0.5 of an inch at its top position. And that's because we've got a base height, a vertical edge of 0.25, and then the actual shape itself, 0.25, sitting on top of that. So these values of base height and either limit or scale to height are cumulative. Again, we could hit Start New Component, click on the last shape we've got here, and maybe we'll specify an angle 45 degrees, base height of 0.1, limit to height of 0.1, and go ahead and hit apply. And there we can see we've actually created kind of a chamfered effect around the outside of the letter there. Once more, cumulatively, we know that the base height is 0.1 plus our limit to height of 0.1, which means that the actual height of that component is going to be 0.2 of an inch. Once we've finished creating components with the Create Shape tool, we can hit close, and we can see those now have been all added to the component tree. Click through from the component tree and select each one of those shapes individually in order to work with it some more, to edit it or manipulate it using the component editing tools. Now there's one more option within the Create Shape feature that we haven't yet looked at. To demonstrate that, I'm just going to delete everything we've created so far. So I'm going to select the top component in the tree here, shift and select the bottom component, which will pick them all, right mouse click and choose the option to delete again. And now I'm just going to click on our circular vector, click on it again to go into transform mode. I'm going to put the cursor over the center, hold shift down so I can click and drag this horizontally so that it slightly overlaps the rectangle next to it. Now what we're going to do is go into the Create Shape feature again. I'm going to click on the rectangle first, and I'm just going to make this 45 degrees, no limit, and I'm going to hit apply. Now I'm going to click on the button to start a new component. I'm going to select the circle, and we'll go with 30 degrees for that also. Again, I'm going to hit apply. Now I can see at the moment, as they overlap, they're basically being added together. What we can do is change the combine mode here to merge so that you can see my dome is sort of being blended into the rectangular shape we've created. Now in a number of modelling cases, what I'd actually like is for my dome to sit so that it looks like it's in front of the rectangular shape that we created here. To do that, we can use the option to tilt that dome upwards. In effect, that's going to create an angled plane underneath it. So like with the base height where we could just raise it up, the tilt has a similar effect, but we can control that, tilting it up in different areas of the shape rather than just raising it all up. To use that, I check the box here and then I click on the button to set anchor. What the software is now expecting me to do is to pick 2 points within the 2D view. The first point we choose, and you can see the cursor is showing me I'm going to pick a point, is going to be one that is going to stay on the modelling plane. So effectively this is the point we're going to tilt up from. So if I click here, just around the left hand side of the shape, that point has now been set, and you can see we've got this dashed line. If I come over here, the second point that I'm going to choose is going to be the point we're going to tilt upwards. So in effect, if I click there, we can see what the software's done is tilt from this side up to this side based on this angle which is set over here, which is currently set at 10 degrees. If we look at this now, we can see how that has affected our shape. So remember, we clicked here and here, which is the equivalent of this point, and there's our 10-degree angle underneath our domed shape. Now what we may want to do is come into here and just click on the little arrow next to it and use a slider to reduce that, or we might actually come in and enter a value itself and hit apply. And there we can see we could just work on that angle so that we get just enough to make it appear that our round dome shape is sitting in front of the one next to it. And that's really what the tilt function is used for, to go ahead, create a shape and tilt it up to overlap with an adjacent shape. Another function of the tilt though would be just to create an angled shape. If we combined it by using the flat profile and the tilt, then we're just going to get a flat wedge shape, and again, for some applications that could be a shape you actually want to make in order to represent the objects in your design. If we were happy with this, we could now hit close, and there again we've got our two shapes in the component tree we've created. You can see the combine mode indicated is based on what we selected in the form. So the first shape was created to add, second shape was created to merge. At this stage, it's important to point out that when we make a shape in the software with any of the modeling tools, that the component we create is not connected to the vector that was used to make it. If I click here and go into transform mode and just drag this out the way, you can see that the vector we use just stays in place. The only time there's any connection between the two is at the moment we hit the calculate button within the modeling tool, and that's when the software is going to use the vector data and the options that we've chosen within the form in order to create the component. After that, there's absolutely no connection between the two. There is one thing that a vector will remember though, and that is the parameters that were used within the create shape form if that vector has been used to make a component. So if I was to come back into the create shape form now, I'll just select, or deselect rather, by clicking in the white space, click on the create shape icon. If I select any of these vectors, you'll notice that the parameters change within the create shape form, and they reflect what the last shape was that was used with that vector and the create shape form. So if we click there, we can see that when we used this teardrop earlier, the last shape we made with that was 30 degrees, base height 0.25, scale to height 0.25, and that information is remembered once we've used a vector in order to create a shape with the function. And that memory that a vector has for the create shape settings will also be transferred across parts if you copy and paste vectors from one session of Aspire to another. So in conclusion, you can see what a powerful feature create shape is, and how depending on the vector you choose and the options that you've selected within the form, there's a large variety of different component shapes that you can create with it. You'll see this feature used extensively throughout the modelling tutorials, and also combined with the other modelling features within the software to create individual components or groups of components to make something more complex. That's the end of this video.